You take a pill for a headache, you feel better, and that's it. You move on with your day. We think a lot about how medicine works, but have you ever stopped to wonder, after it's done its job, where does it actually go? Turns out, your body has this whole sophisticated exit strategy. Let's trace that journey.
So here's our game plan. We're going to look at a drug's basic exit strategy and then meet the two main players responsible for the cleanup. After that, we'll see how this balancing act works in the real world, what happens when the system just gets overloaded, and finally, what happens when two different drugs are literally competing for the same way out.
All right, let's dive in. Because really, a drug doing its job is only half the story. How your body gets rid of it afterwards, that's just as critical for keeping you safe and healthy.
So yeah, this is the big question. Once a drug has worked its magic, it can't just hang around in your system forever. Your body needs a super efficient plan to clear it out and get everything back to normal.
And this whole cleanup process has an official name, elimination. It's just the sciencey way of saying how your body breaks down or removes a drug, causing that concentration in your blood to drop, drop, drop.
So how does this whole elimination thing actually happen? Well, the body has a fantastic two-part cleanup crew on the job. Let's meet the team. The two superstars here are your liver and your kidneys. First up, the liver handles metabolism. Think of it like a chemical processing plant that completely changes the drug, breaking it down into other things called metabolites. And then you've got the kidneys, and they handle excretion. This is more like a filtration system, just pulling the original, unchanged drug right out of your blood and sending it out in your urine. Now, these two don't work separately. They're a team. The overall speed of elimination, which scientists call K, is simply the speed of excretion, Ke, plus the speed of metabolism, Km. So you got team kidney speed plus team liver speed. Their combined effort is what decides how long a drug actually hangs around. Okay, theory is cool and all, but let's make this real. We're going to see exactly how the body manages a dose of a drug, and more importantly, what can happen when that delicate balance gets thrown off. So, let's imagine we're tracking a single 100 milligram dose of some drug. Once it's in your system, as you can see here, it's got to pick a door. Door number 1 is metabolism. Door number 2 is excretion. The real question is, how does the body split up the work? All right, here's our starting point, 100 milligrams. It's all absorbed, it's in the system. And now, the cleanup crew clocks in. And here are the results. In lab tests, scientists find 70 milligrams of that original drug completely unchanged in the urine. That number tells us exactly how much work the kidneys did all by themselves through excretion. This just shows the split perfectly, doesn't it? A whopping 70% of the drug was handled by the kidneys, just booted out as is. Which means the other 30% had to be taken care of by the liver's metabolism machinery. So for this drug, excretion is clearly the main highway out. Okay, but this brings up a huge question. What if someone's kidneys aren't working well? What happens if that main 70% exit route is blocked? And this isn't just a thought experiment. It's a massive deal in real-world medicine. And here is the bottom line, right from the source material. If that main pathway is out of commission, the drug can build up to dangerous, even toxic levels. This is exactly why doctors are so careful about adjusting dosages for patients with kidney or liver problems. And wow, these numbers really tell the story. Look at this chart. In a person with healthy kidneys, the drug's half-life, that's the time it takes to get rid of half the dose, is just 2 hours. But with impaired kidneys, that half-life shoots up to almost 7 hours. The body just can't clear it fast enough, and that's exactly when a helpful medicine can become harmful. But it's not just a damaged system that can cause issues. Sometimes the problem is that we overwhelm a perfectly healthy system, creating a kind of metabolic traffic jam. So under normal circumstances, your body's cleanup crew is incredibly smart and responsive. It's called first-order elimination. All it means is the more drug there is, the faster the crew works to clear it out. It's a proportional system, which makes a lot of sense. But what if you take way too much of something? The enzymes in your liver can get totally saturated. They're all busy. And this flips a switch to something called zero-order elimination. It's like an assembly line that's hit its absolute max speed. No matter how much more stuff you pile on, it cannot work any faster. The rate of elimination just flatlines. And that's exactly where the danger is. When that system is saturated, the drug level can just keep rising and rising. Your body loses its ability to keep up, and that makes an overdose way more likely.
Okay, last scenario. What happens when it's not just one drug trying to get out? I mean, lots of people take more than one medication, and sometimes this creates a competition for the exact same exit door.
The problem kicks off when one drug acts as an inhibitor. It basically gets in the way of the enzymes that are supposed to be processing a different drug, clogging up the whole pathway.
And you can see it perfectly in this picture. You've got the drug that needs to be processed, the enzyme it's trying to connect with, and then this inhibitor molecule comes along and just parks itself right in the docking bay, blocking the whole connection. This is called competitive inhibition. Both drugs are literally fighting for access to the same enzyme. It's like two people trying to shove through one doorway at the same time. This traffic jam slows everything down for the primary drug, which means its levels can climb higher and higher, potentially becoming toxic. This is why it is so important that your doctor knows every single thing you're taking. So, from the cleanup crew in your liver and kidneys to system overloads and drug-on-drug competition, a medicine's journey out of your body is just as complicated and fascinating as its journey in. It's this hidden, crucial process that's constantly working to keep us safe. So, maybe the next time you take a medicine, you'll stop and think, what's its exit strategy?